students, this is a Maths Worksheet 27, chapter number 4, Basic Geometrical Ideas. Dear students, you will also follow COVID appropriate behavior, so you wear mask, follow physical distancing and maintain hand hygiene.
Now here we will discuss curve, right? What is curve? So any drawing, straight or non-straight, okay, done without lifting the pencil may be called a curve, like this figure, right? Here if we start from this point, like this point, and we continue move with last end of this point. So here and give the name of this point as A, right? And we take another point here and give the name of this point as B. This type of figure is known as curve shape, right? So here first we start from, and first we will discuss a simple curve. A simple curve is one that does not cross itself, right? Like this first figure here, this one. Now open curve and close curve. A curve is said to be closed if its ends are joined. Otherwise, it is said to be open, right? These two figures are example of closed curves, and these two figures are example of open curves. Now open and close curves. An open curve has two endpoints and it does not have enclose an area. Okay, it does not enclose an area. So these are some figures related to open curves, right? Now here we will discuss closed curve. What is closed curve? A closed curve has no endpoints and completely encloses an area, like this first figure, this second figure and the third figure. So this figure has enclosed a specific area here, right? So closed curves include circles, ellipses and ovoids. Okay, alright. So basically open curves are those curves, those figures not enclose an area, and closed curve are those figures which enclose an area. Okay, so here this figure having two ends here. If these two ends, right, if these two ends not join with each other, so here we say that these type of figure are known as, and these type of curve are known as open curve, right? These type of figure are known as closed curve, where these two points join with each other, these two ends join with each other. And if these two points are not joined with each other, so here we say that these type of curve are known as open curve. And simple curve having basically two parts, open simple curve and closed simple curve. Okay, where the 2 points and 2 ends are not meet with each other, here we say that these type of curve are known as open simple curve. And if these 2 points meet with each other, so here we say that these type of curve are known as closed simple curve. Now students, here we will discuss polygons. So polygon is any closed two-dimensional shape formed with straight lines. Okay, so polygon are basically figures where we use straight lines, right? And these two-dimensional figure formed by straight lines. Now classification of polygon. So first type, based on relation between sides and angles and based on number of sides, right? So regular polygon. So regular polygon having equal side and equal interior angles. Okay, like this square. Now irregular polygon. Not all sides or interior angles are equal in these type of irregular polygon, right? Now equilateral polygon, where the all sides are equal. So these type of polygons are known as equilateral polygon. Now equiangular polygon, all interior angles are equal. In these type of polygon, all interior angles are equal, like this figure. These all angles are 90 here. Now convex polygon, all interior angles are less than 180. In these type of polygon, all interior angles, interior mean angles formed inside the figure. So these type of polygons are known as convex polygon. Now concave polygon, at least one interior angle is more than 180. So in this type of polygon, there is one interior angle is more than 180. Right? Now here we will discuss classification of polygon on the basis of number of sides. Now triangle, polygon with 3 sides. If the polygon having total 3 sides, here we say that these type of polygon are known as triangle. Now quadrilateral, polygon with 4 sides. If the polygon having total 4 sides, so we say that these type of polygons are known as quadrilateral. Now pentagon, so polygon with 5 sides. If the polygon having total 5 sides, so we say that these type of polygon are known as pentagon. Now hexagon, polygon having 6 sides and polygon with 6 sides. If the polygon having total 6 sides, so we say that these type of polygon are known as hexagon. Right? Now heptagon, polygon with 7 sides. If the polygon having total 7 sides, so we say that these type of polygon are known as heptagon. Now octagon, and octagon having total 8 sides, so we say that these type of polygon are known as octagon. Nonagon, nonagon having total 9 sides. Decagon, decagon having total 10 sides. Right? So here we discussed classification of polygon on the basis of sides and angles and number of sides. Now here we will discuss angle sum property of polygon. Interior angles. For n-sided polygon, sum of all interior angles is equal to n minus 2 multiplied by 180 degree. Right? For n-sided regular polygon, measure of each interior angle is equal to n minus 2 upon n multiplied by 180 degree. So here we write n-sided mean the total side is equal to n here. Here we put the value of total side in the place of n. Right? Now exterior angle. Right? Exterior angles. For n-sided polygon, sum of all exterior angles is equal to 360 degree. Right? For n-sided regular polygon, measure of each exterior angle is equal to 360 degree upon n. If we divide 360 degree by total side of polygon. Now here I will show you different figures of polygons according to their sides. Now triangle, triangle having total 3 sides and sum of the interior angles is 180 degree. Now quadrilateral, and quadrilateral has total 4 sides and 4 vertices, and it has total 2 diagonals, and the sum of the interior angles is 360 degree. Now pentagon, pentagon having total 5 sides, and the figure of this pentagon like this, and sum of the interior angles is 540 degree, and the total diagonals 5 diagonals. Now hexagon, hexagon having total 6 sides and it has total 9 diagonals, and sum of the interior angles is 720 degree. Now heptagon, heptagon figure is this, and it has total 7 sides, and it has total 14 diagonals, and sum of the interior angles is 900 degree. Right? Now octagon look like this figure, and it has total 8 sides, and it has total 20 diagonals. Right? Sum of the interior angles is 1080 degree. Remember this point, sum of the interior angles of octagon is 1080 degree. Now nonagon, and it has total 9 sides and 9 vertices, and it has total 27 diagonals, and sum of the interior angles is 1260 degree. Now decagon having total 10 sides, 10 vertices, and it has total 35 diagonals, and sum of the interior angles is 1440 degree. Now students, here first we'll discuss here angles. Right? An angle is a measure of the rotation or turn of a ray about its fixed point. The fixed point is called the vertex, right, whose plural is vertices. If there is only one point or a one fixed point known as vertex, and if the figure having more than one, so we say that these are the vertices in the angle. So the diagram below shows how an angle is formed when the direction of turn is clockwise, and the amount of turn shown by the red arrow is the measure of the angle. Right? So this is the figure related to angle. So here first we will discuss about how angle form actually. Right? So basically this point, this first ray is the initial position of ray, and from this point this ray move from here to here. Right? So when this ray move from initial point to final position, so this point it makes some angle here, right, in the middle of these two ray. So the amount of turn is the measure of the angle. Now the initial point of these two rays is known as vertex. Right? So this point is known as vertex of the angle. So the above definition is based on a more dynamic view of an angle that is consistent with the newer geometries often referred to as motion geometry. Right? What is it? Motion geometry. In Euclidean geometry, a more static view of an angle was envisioned. Right? In this view, angles are seen as a static form when two rays meet at a point called the vertex. So now here we will discuss classification of an angles. So here classification of angles by size of turn. So you all know that here ray move from its initial point to final point, right? So angles are classified according to the size of the turn. Okay, so there are some angles based on their size of turn. Now measure of an angle and name of the angle. So angle which less than 90 degree known as acute angle, and angle which exactly 90 degree known as right angle. The name of the angle is right angle, right? Now greater than 90 but less than 180. So these type of angle are known as obtuse angle, which are greater than 90 but less than 180. Now angle which is exactly 180 degree. So these type of angle are known as straight angle, right? Straight angle, and it is a half turn of the ray. The ray complete its half turn at 180 degree. Now greater than 180 degree, the angle which are greater than 180 degree are known as reflex angle. So the angle which are greater than 180 degree are known as reflex angle. Now 360 degree, the angle which is exactly 360 degree known as complete angle, and it is a full rotation or whole turn, right? So these are some types of angle based on their turns. So you all know that when we measure an angle we use protractor, right? So this is the figure of protractor here. This is an anti-clockwise turn. So when the ray move from this point to this point, this turn is known as anti-clockwise turn, right? The amount of turn in this case lies between 30 and 40 degree, right? 30 and 40 degree. So seen on the inner scale, right, at this point, right, from here. So here we say that this is 35 degree angle. Okay, so we use the outer scale and this give us as reading of 35 degree. Now this picture shows clockwise turn because ray start move from this point to this point, right? So this is a clockwise turn and the amount of turn in this case lies close to 50 degree, right, at this point. And seen on the outer scales, when we move clockwise, so here we check angle from outer scale, right? A closer look at the outer scale give us a reading of 49 degree, right? Here there is no need to read the inner scale. This would give us the measure of the supplement of the angle we just measure, right? So here we say that this is 49 degree angle. So dear students, by using this protractor you will easily find what.
Now students, here we will learn about how to draw a circle if the radius is given, right? So
how we draw a circle here.
So if their radius is given here, like radius equal to 2 centimeter, right? And here we also make another circle here, right? So how we draw a circle? So it's required one ruler here, right, and one compass, and I already fixed this pencil inside the hole of this compass. So here first we measure 2 centimeter on this scale. Okay, so here we put this tip of this compass on the scale and the pencil on 2, right, on 2 centimeter. And remember students, here you measure exactly 2 centimeter here, otherwise your circle is not formed 2 centimeter radius perfectly. Now put the tip of this compass on the paper and rotate like this. Join
this center and the edge of this circle here, and give the name of this center as O and this point as A. Now this OA line segment is equal to 2 centimeter. Here we measure the length of this line segment here is equal to 2 centimeter. So here we write R equal to 2 centimeter, and if you find the diameter of the circle, so here you all know that diameter is multiply by 2 of the radius, right? So 2 2s are 4. So here we say that diameter equal to 4 centimeter. Now we take another example here, and here R equal to 4.5 centimeter, right? 4.5 centimeter. So here you again measure 4.5 centimeter on the scale. So put this tip, the starting point of this ruler here, and shift pencil on 4.5 centimeter, right? Now remember one thing here, you not change the distance of pencil and tip of this compass here. Now put the tip on this paper and rotate like this. Now one circle is formed here, and now here I give the name of the center point as O and join this point from the edge of the circle here, right? Now this is the R of the circle, 4.5 centimeter. You also measure the distance and the line segment O and give the name as P here, the outside point as P. Okay, so here we get 4.5 centimeter. And what is the length of the diameter? So you all know that diameter equal to 2 into R, right? So we multiply 2 by 4.5 centimeter, so here we get 9 centimeter. Okay, so here you say that diameter equal to 9 centimeter, and here diameter equal to 4 centimeter, right?
Now next here we solve one question related to circle, and here we will discuss interior and exterior points of the circle. Okay, we will take some points from the circle P, S, T, A, G, R, right? So here we find interior points, exterior points, points on the circle. So what are the interior points? Interior points are those points which lies inside of the circle. Points like P, S, O and G. These points are lying inside of the circle, so these points are known as interior points. So we write P, S, O and G are interior points. What are the exterior points? Points which lie outside of the circle. What are the points? R and T are the points which lies outside of the circle. So these points are known as exterior points. Right? Now points on the circle mean there is any point which lies on the circle, so there is A. Okay? So we say that A is the point which lies on the circle. Now here we take another example related to interior and exterior of an angle. Now here we take another example related to exterior and interior points of an angle. So now, what are the interior points in angle? So points which lies inside, in this part of the angle are known as interior points of an angle. So what are the points here? X and Q. Now exterior points, points which lie outside of this angle are known as exterior points. So P, right? P is the point which lies outside of this angle. Now points on the arms. So points on the arms mean points which lies on the arms are known as and we say that these points are lies on the arms. So B, Z, O, T and A. These are the points which lie on the arms. So we will write A, T, O, Z and B. Right. Now what is vertex here? So we will say that the initial point of this of the both rays are known as vertex. So here O is this point here. So these are the interior points of this given angle, exterior point, point of the arms and vertex.